Welcome back, Chemistry 30. So this is the second part of the 1.5 video. So I left you with this to see if you could come up with the structure of the sulfate ion. So we'll see if we can make our way through it. So of course those S's, the S will be the central atom, the O's will be around it. Now since it's an ion, of course, to show that we put the square bracket. And I'll just put these around here and we'll see what we end up with. So we know the sulfurs are good, or so the oxygens are good, 2, 4, 6, 8, 8, 8, 8, and 8 times 4 is 32, so everything is good there. And if we look at the sulfur, 2, 4, 6, 8, the sulfur looks good too. So at first glance, this looks like the correct structure for the sulfate ion. But if we look at where sulfur and oxygen fall, they're both group 6. So they should have 6 valence electrons. So I'm just going to write 6's all the way around here. And for that central S, we have 6 as well. If we do the little calculation, we'll see that there's an issue. So the oxygen, this oxygen should have 6 electrons, but if you take a look, 1, 2, 3, 4, 5, 6, 7. It has 7, which is going to give us a formal charge of -1. Same thing with this one. Same thing with this one, because they're all the same. And same thing with this one. If we look at the central sulfur here, 1, 2, 3, 4. There's a formal charge of +2. So there's an issue there. None of those are 0. The oxygens have 1 too many. The sulfur is 2 too few. So what we're going to have to do here is with 2 of these oxygens, we're going to have to bring a pair down and share with the sulfur. And that will solve the problem. It'll give us 0 formal charges for 2 of those oxygens. So if we do that, so if we assume that one pair went there, and with this oxygen, that one pair that I outlined here went up and formed that, then we have single bonds still with these oxygens. Big bracket, 2 negative. If we do that same calculation now, we'll see that it will work out. So oxygens should have 6, sulfur should have 6. Take a look at what we have here. 1, 2, 3, 4, 5, 6. So this oxygen is good. This one, 1, 2, 3, 4, 5, 6. Okay, it's still not good, but we'll see that that's okay. 1, 2, 3, 4, 5, 6. This oxygen's okay. And then this one, 1, 2, 3, 4, 5, 6, 7. Okay, we're no good there. And the sulfur should have 6, and it has 1, 2, 3, 4, 5, 6, 0. And so everything is 0. So 0, 0, 0, -1, and -1. But you know what? That's okay. So it's showing that there were 2 negatives that were gained. And that's in fact what should have happened because it is the sulfate ion. So there should be a gain of 2 electrons. So isn't that neat how that works out? Now you notice that, oh, but sulfur doesn't follow the octet rule. Now it is 2, 4, 6, 8, 10, 12. That's okay. Because correct formal charge values takes precedent. I think that's how you spell it. Takes precedent over the octet rule for the central atom. Okay, so that's one thing that we have to take into account. The formal charges takes precedent over that central atom having the correct number of following the octet rule. Now, if you look at the assignment for this, you may get some deja vu, because guess what? It is identical to the MS1.3 assignment. So all you have to do is go back to the 1.3 assignment, and you can copy out what you had here, because we want to draw the best Lewis structure using formal charges. So if I look at this first one, for example, this is what you would have got for when you did this with 1.3. If you look at formal charges, hydrogen is group 1, so it should have 1 valence electron. Chlorine, of course, is group 7. So there should be 7 electrons there, and carbon is group 4, so there should be 4. If we look at what's happening with hydrogen, here's hydrogens, 1 minus 1, yeah, it's good. Good, 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 all the way around the table. Chlorine, 1, 2, 3, 4, 5, 6, 7, it's good. And carbon, 1, 2, 3, 4. 4 minus 4 is 0. So it's good, as is. So it just so happens that that gives us the best one. Over here, carbon disulfide, I think you would have found that you would have had to make these double bonds. And if we look at sulfur and carbon, sulfur, of course, is 6, carbon is 4. So sulfur, 1, 2, 3, 4, 5, 6, it's good. 1, 2, 3, 4, 5, 6, it's good. Carbon, 1, 2, 3, 4, 4 minus 4, it's good as well. It's good. But if we look at the flip side, see, I have it worked out here somewhere. Here it is. So if you look at this one, so I think you would have found by using our method back in 1.3 that the structure looks like that. It makes sense. There's 24 electrons, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. And if we bring that set of electrons down here, 2, 4, 6, 8, nitrogen is 8, each oxygen is 8. It looks good until we look at formal charges. So oxygen is group 6, nitrogen is group 5. So we'll do the formal charge calculation here to see what happens. This oxygen, 1, 2, 3, 4, 5, 6, 7. Uh-oh, we get a -1. Same thing with this one, we're going to get a -1. This one, 1, 2, 3, 4, 5, 6, it's good. And nitrogen, 1, 2, 3, 4, +1. So this is good, but something is array here. We should have just one of them being -1. So that means that 2 of these are going to have to balance out. And we can see here this oxygen is 1 too many, or this one has 1 too many. I can pick whichever one I want, but we can see here we're going to have oxygen involved with sharing that electron set. Because nitrogen needs 1, oxygen needs to lose 1. So if you look at what happens with that, so this one stays the same. This one we're going to make a double bond. This one's going to stay the same. Put the old bracket, make it work. And then if we do that calculation now, I think we'll see it works. So this oxygen should have 6 electrons, but it has 7. That's okay. And this oxygen, 1, 2, 3, 4, 5, 6. 6 minus 6 is 0. This one, 1, 2, 3, 4, 5, 6. 6 minus 6 is 0. And nitrogen, 1, 2, 3, 4, 5. It's 0. 0, 0, 0. One of those is -1, which is fine because it's the nitrate ion. It should have an additional 1 electron. So you can do the rest of that assignment. That's how you handle it with the formal charges. See if those structures that you did in MS1.3 are valid by comparing the formal charges of each element. And if it's not, see if you can make the change to make it so. All right, we'll see you again.